Argentina, Bolivia holds more than half of the world's known lithium reserves, yet many local communities see few benefits and face most of the risks. The clean energy transition is in practice an extraction boom in someone else's backyard. So why are we doing it this way? Why stick with these massive, water-hungry evaporation ponds? One reason is simple. They're cheap. The sun and the wind do most of the work. Once the ponds are built, operating costs are relatively low compared to more sophisticated technologies. For investors and mining companies, that's attractive. For governments trying to quickly scale up lithium production to meet huge global demand, it's a straightforward, proven method. But there's another reason. For a long time, we simply didn't feel the costs. The people paying that water bill, indigenous communities, small farmers, fragile ecosystems, had little visibility in global conversations about climate solutions. Their voices were easy to ignore in boardrooms in London, New York, or Beijing. That's starting to change. In Chile, debates over lithium and water have become national news. Environmental scientists, community leaders, and activists have pushed the government to rethink how lithium is extracted and who controls it. The country's leadership has announced plans to phase out traditional evaporation ponds over time and promote a new set of methods known as direct lithium extraction, or DLE. DLE sounds like the magic solution. Instead of spreading brine out in open ponds for more than a year, you run it through special filters, membranes, or chemical absorbers that selectively pull out lithium. This can cut the extraction time down to hours or days, and crucially, in some designs, a large portion of the water can be re-injected underground instead of being evaporated away. Sounds perfect, right? Faster, less land-intensive, potentially far less water wasting. But, and there's always a but, most DLE technologies are still very new. Many haven't been proven at large commercial scale yet, and some require significant energy or additional chemicals. The question is, will DLE really reduce environmental damage overall? Or will it just shift the impact into different forms, like higher energy use? Meanwhile, global demand is exploding. Every government that announces a deadline to phase out combustion cars is indirectly increasing pressure to mine more lithium faster. Projections suggest lithium demand could nearly quadruple by the end of this decade. Automakers are signing long-term contracts with miners, oil companies are rebranding themselves as energy companies and buying into lithium, and countries from Serbia to the UK to the US are racing to open new mines or brine projects. In Norway and the UK, there's talk of reviving old mining regions to extract lithium locally, pitching it as ethical or European lithium. In California's Salton Sea region, companies are planning geothermal lithium projects that combine renewable power and DLE, presenting them as a cleaner alternative. Everywhere, the same promise echoes. This time, we'll get it right. But if we're honest, we're running the same playbook we used for oil, copper, and coal. Rush in, extract as much as possible, hope technology fixes the mess later. Here's where things get even more uncomfortable. An average electric vehicle contains far more mineral content than a conventional car, not just lithium, but also nickel, cobalt, manganese, graphite, copper. All of that has to be mined somewhere. If we simply swap every gas and diesel car on Earth for an electric one, we're not just changing the energy source, we're building an entirely new global mining industry on an unprecedented scale. So the real question isn't just, are EVs cleaner than combustion cars? They are, especially when powered by greener grids. The deeper question is, how much damage are we willing to accept in the name of clean? And who gets to decide that? If you talk to communities in the lithium triangle, many will tell you they were never really asked. They see deals between governments and foreign companies, contracts worth hundreds of millions of dollars, and hear about national progress and green transitions, while watching streams shrink and fields crack. Some communities are pushing back hard, organizing protests, filing legal challenges, and demanding a real say in how these projects are run, or whether they should exist at all. At the same time, others still hope lithium can be their ticket out of poverty if done right, with proper revenue sharing, jobs, and environmental protections. It's not a simple story of mining bad, locals good. It's a messy human story of competing needs and visions for the future. So where does that leave you, the person thinking about buying an electric car? Let's be clear, going back to petrol isn't the answer. Sticking with fossil fuels guarantees more heat waves, more climate disasters, and more suffering, especially for the same vulnerable communities who are now on the front lines of lithium extraction. Electric cars are a crucial part of cutting emissions, but they're not morally neutral just because they have a battery instead of a fuel tank. There are ways to make this better. One is obvious but not sexy. We need fewer cars overall, not just cleaner ones. That means better public transport, walkable cities, bikes, and shared mobility. Every car we don't build is thousands of gallons of water and hundreds of kilos of mined rock that never have to be disturbed. Another is recycling. Right now, only a small fraction of lithium batteries are fully recycled. As the first generation of EVs and large battery packs reaches end of life, there's a huge opportunity to recover lithium, nickel, and other critical materials and reuse them instead of tearing up new landscapes. Some companies and researchers are racing to develop efficient recycling methods and circular supply chains. The question is whether policy and industry will move fast enough to make this the norm, not the exception. And there's a hidden tension here. Recycling only becomes powerful at scale once millions of batteries actually reach the end of their life, which means for the next decade we're still leaning heavily on fresh mining. So we're in a double exposure period where both extraction and manufacturing are ramping up, but recycling is still crawling. That's why decisions made now about battery design, how easy cells are to disassemble, and how transparent supply chains are will decide whether recycling becomes a real pressure valve on mining or just another green buzzword printed in annual reports. Then there's accountability. Car makers love to market their green credentials, but how often do you see them talk about where their lithium comes from, what extraction method was used, or how much water was consumed per battery? Very rarely. Some brands are starting to publish more detailed sustainability reports and traceability data, but it's still patchy and hard to compare. Imagine if next to range and 0 to 100 kilometers per hour, there was another stat on every EV spec sheet: estimated water use and land impact per battery. Suddenly, that 1,000-gallon number would be harder to hide. And finally, there's something deeper: honesty. We have to drop the fantasy that there's such a thing as impact-free technology. Every phone, every car, every solar panel, every wind turbine requires materials that come from somewhere, often from places where people have less power and voice. So the real ethical choice isn't between clean and dirty, it's between a transition that repeats the same old extraction patterns, just with greener branding, and a transition that genuinely respects limits. Limits to how much we take, how fast we take it, and how we share both the burdens and the benefits. Next time you see an ad of an electric SUV speeding silently through a pristine landscape, remember the other landscape it doesn't show you. The blinding salt flats, the endless evaporation ponds, the communities counting liters of water while we count kilowatt hours. Somewhere in the Andes right now, a pump is still running, pulling brine from deep below a 1,000-year-old desert. That flow will eventually become a handful of white powder, lithium carbonate, destined for a future battery. Months or years from now, that battery might sit under the floor of a car quietly charging in a suburban garage, its owner proud to be going green. The question is, when we talk about the dark side of electric cars, are we willing to look at that pump, that desert, and those people, and admit they're part of the story too? If you want more deep dives into what really powers our modern world, beyond the slogans and shiny marketing, hit subscribe, share this video with someone who thinks green automatically means guilt-free, and let me know in the comments, after seeing how one battery can drink 1,000 gallons of water, do you look at electric cars differently?